You know, when I say rainwater harvesting, what pops into your head? Probably a simple barrel under a gutter, right? Kind of old-fashioned. Well, what if I told you that ancient practice is actually at the very center of a huge, modern, scientific revival? It's being used to tackle some of our planet's biggest water challenges. So yeah, let's dive in and see what the latest research is all about. Okay, so how much attention is this topic really getting in the scientific world? Well, get ready for this number. 3,857. That is the number of scientific papers published on rainwater harvesting in just one major research database. But here's the kicker. It's not the what, it's the when that's really going to blow your mind. Get this. A staggering 80% of all scientific research on rainwater harvesting has been published since 2010. And about half of that just in the last 5 years. This isn't some slow-burning interest. We're talking about a massive, recent explosion in scientific study, and it's all driven by a powerful new sense of urgency. Right, so this brings us to our first section. This ancient idea is now facing a very modern urgency, and that urgency isn't just in one or two places. Scientists all over the world are suddenly focusing on this, all because they're grappling with the twin pressures of water scarcity and, you guessed it, climate change. Let's see where all this research is actually happening. This chart tells a really interesting story about who's leading the charge. Right at the top, you've got the United States and India neck and neck with nearly 500 publications each. China is right on their heels, and then you see these major players like Germany, the UK, and Australia. So what's the common thread here? Well, most of these countries are either already dealing with serious water stress or they're getting ahead of the curve, proactively investing in sustainable water for the future. So, with all this new brainpower being thrown at the problem, you can bet the technology has come a long, long way from that simple barrel we talked about. We are now officially in the era of the high-tech harvest. Let's dig into what that actually means. This is where it gets really cool. We're talking about smart rainwater harvesting. And by smart, I mean we're integrating things like sensors, the Internet of Things, and even artificial intelligence. These systems aren't just sitting there passively collecting water anymore. Oh no, they are actively monitoring data, like weather forecasts and how full the tank is, to make smart, optimized decisions in real time. So what does that look like in the real world? Imagine this. A smart system sees a huge storm is on the way, so it preemptively lets some water out of its tank to make room for the downpour. Just that one simple action helps stop the tank from overflowing and takes a huge burden off the city's sewer system. It's a total game changer because it's predictive, not just reactive. And this isn't some sci-fi future, it's happening right now. Take Amsterdam, for example. Their smart blue-green roofs project is just incredible. It's a green, vegetated roof, but underneath there's a water storage layer, and the whole thing is controlled by a smart system that's constantly checking the weather. It holds onto water when it's dry to keep the plants happy, and it releases it before a big storm to protect the city from flooding. It's basically urban infrastructure that can think for itself. Okay, but with all this amazing tech, we have to ask a really fundamental question. We all kind of assume that rainwater is pure, clean, but is it really? And this brings us to the hidden dangers lurking in that water. Yeah, it turns out rainwater is far from pure. It can carry three main types of nasty stuff. First, you've got microbial contaminants, and we're talking serious pathogens, like Legionella here. Then there's chemical contamination, like heavy metals that can literally leach out of certain roofing materials. And finally, there's all the physical gunk: dust, soot, particles from car exhaust, you name it. So how does all that junk get in there? Well, there are two main ways. The first is called wet deposition. That's when the rain itself literally washes pollutants out of the air as it's falling. The second is dry deposition, and that's all the dust, leaves, and soot that's already sitting on your roof, just waiting to get washed off by that first flush of rain. The takeaway here is huge. Both the air quality and how clean your roof is have a massive impact on your water quality. Okay, so the water can be contaminated. That sounds like a pretty big problem, right? But it's a problem that engineers have a really elegant answer for. It's called a multi-barrier approach, and it's the path to getting truly pure water. The solution is what engineers call a treatment train. And the whole idea here is that you never ever rely on just one single method. It's all about layers of protection. You start with pretreatment, think screens and something called a first flush diverter, which basically gets rid of that first really dirty gush of water. From there, it goes through different kinds of filters to pull out smaller and smaller stuff. Then you hit it with some advanced purification. And finally, you disinfect it to zap any nasty pathogens that might be left. See? Each step is like a new barrier, a new layer of safety. And what's really exciting is that innovation is happening at every single one of these stages, especially with membrane technology. The old school systems needed these high-pressure pumps that just guzzled energy, but the newer tech called gravity-driven membranes, or GDM, uses nothing but the force of gravity. This completely slashes energy use and makes the whole system more stable and perfect for smaller, decentralized setups. Now for that final step, disinfection. You've got options and each one has its pros and cons. UV is great because it's chemical-free, but it doesn't work well if the water is cloudy. Chlorination is super reliable, but it can make the water taste a little funky. Boiling is obviously super effective, but man, does it use a lot of energy. So the real pro tip here is that the best strategy often combines a few of these methods to create a system that's totally robust and foolproof. All right, we've got the tech and we know how to make the water safe, so now let's zoom out and look at the bigger picture. Because when this is done at scale, rainwater harvesting creates a global ripple effect. We're talking huge environmental benefits and brand new policies popping up all over the world. And the environmental wins are massive. I mean, think about it. By using water right where it falls, you cut down on the huge amount of energy needed to treat and pump water from a central plant. You reduce urban runoff, which helps stop flooding. You can even help recharge depleted groundwater. Plus, you're giving your garden naturally chlorine-free water, which plants absolutely love. It is a win-win-win. So how are governments actually making this happen? Let's take a look at Germany. They are, without a doubt, a global leader here. We're talking over 1.8 million systems installed. And they do it with smart financial incentives. For example, they charge a separate fee for rainwater runoff, which gives you a direct economic reason to capture it yourself. And they offer subsidies to help you pay for the installation. Smart, right? Now, Australia, which has its own serious water issues, takes a totally different approach. They mandate it. In places like South Australia, it's not just a nice idea, it's the law. If you build a new home, you are required to install a rainwater tank. It's all about building water resilience right into the DNA of their communities. And this isn't just something for wealthy, developed nations. Brazil's Cisterns program is just an incredible example of social impact. They've installed over 1 million rainwater tanks in really arid regions, giving essential water security to vulnerable rural communities and, most importantly, empowering them to manage their own resources. It's life-changing stuff. So when you put it all together, what does it all mean? Well, the global shift is undeniable. We are moving past just cautious adoption. We are now in an era of active encouragement, of standardization. The trend is clear as day. We are watching the world move to integrate rainwater harvesting right into their core national water strategies. And that leaves us with one last big question to chew on. As our cities just keep growing and as our climate gets more and more unpredictable, could it be? Could one of the most effective, most resilient, and most sustainable keys to our future water security have been right there, floating above our heads the entire time?